Hello everyone. In this video we're going to be talking about solving linear equations, specifically the, let's say, more complex version of them. So for example, let's say we have 3 times 2x minus, let's say, 1. This is equal to 4 times 3x minus 2. So as you can see, we have x, the variable, the unknown, at both sides of the equation. So the left side, also the right side. We're also having a bracket and then a number outside in each side. So it's a little bit more complex. We can actually go ahead and make it even more complex, even though it's like pointless, but like we could have added other numbers. Yeah. So it's all the same, so it really doesn't matter. Okay, so in this type of questions, what do we do exactly? Well, if you have watched the order of operation video, it's kind of similar to that. So like, if you have brackets first, you have to get rid of the bracket. And in this case, we have a number times an expression, so inside the bracket. So firstly, you can do this. Okay, so firstly you can multiply 3 by this term and then 3 by the other term, and you can do the same thing for the right side too. So you're gonna multiply 4 by this term and then 4 by the other term, so like this. Okay, so the whole thing becomes this. So 3 times 2x. So we're gonna be using numbers, so ignore the x first. So 3 times 2 is going to be obviously 6, and you can write x again, right, for this arrow. And then for the second one, it's a 3 times 1, which is obviously 3. But this is a positive 3, we don't write the positive, we know it's there, yeah? So positive 3 times negative 1. In multiplication, opposite signs gives always a negative sign, okay? So the same thing we're going to be doing for the right side. So 4 times 3 is going to be 12, and we can write x again. And then 4 times 2 is 8, similarly to this. We're going to be putting the negative sign again. So now we have actually got rid of the brackets. So now we have two types of terms in both sides. So like we have this term which contains x, and the same thing on the other side which contains x again, and these two numbers that are alone and doesn't have x. All right, so from here is just a preference. So basically you have the choice to move the number to the right side and then the variables to the left side, or do the other way around. So in my case, I will choose to have the variables at the right side, so every term that contains x, and then every number alone at the left side. So in this case, I'm going to be leaving 12x here, not moving it, but I'm going to be moving actually 6x to the right side. Okay, so I'm going to be moving 6x to the right side. This is positive 6x. If I move it to the other side, it becomes what? It's gonna change signs. So this is going to be negative 6 if I move it to the right side. The same thing here. So I had negative 3. Yeah, I'm gonna just drop it down because I've decided to move numbers to the left side. So I'm gonna be moving negative 8 to the left side. Now negative 8, if I move it to the left side, it's going to change signs. So negative 8 is going to be a positive 8. Okay. Now just simplify. So 8 minus 3, obviously 5. And then you have 12 of x, so 12 of anything. Like let's say you have 12 bags and then you gave 6 bags to someone else. So we're going to be left with 6 bags, or just 6x, okay? Now, since we're having only a number, an x on one side, on another number on the other side, this is the final step of an equation. So here, every time, you can write it again so that you don't get confused. Every time when you get here, you're going to be dividing both sides by the number next to x. So in this case, it's 6. So divide both sides by 6 so that we cancel that 6. Yeah? So we're going to be left with x at the right side and then 5 over 6 at the left side. And this is actually the value of x. So the solution for this equation is x being equal to 5 over 6.